At the end of this video presentation, you are expected to, number 1, demonstrate your understanding about a piecewise function. Number 2, set up a table of values for a piecewise function to accurately sketch the graph. And number 3, represent real-life situations using functions. We are going to talk about what is piecewise function. Piecewise function is a function defined by multiple subfunctions or sequence of intervals. It means that piecewise function is composed of more than one function. Its domain is divided into parts and each part is defined by a different function rule. We have the examples. Construct table of values for each piecewise function, then sketch the graph. Number 1, y is equal to x if x is greater than or equal to 2. And second one, y is equal to negative 2 if x is less than 2. Take note, there are two different subfunctions here, and each subfunction has a definite function rule because this is a linear function in which our domain is x is greater than or equal to 2. And this is a constant function in which our domain is x is less than 2. Now, how are we going to sketch the graph? The first thing that we are going to do is to sketch first the graph of the number 1 function, which is y is equal to x, in which our domain is x is greater than or equal to 2. This is a identity function. Therefore, identity function is a line. In setting up the table of values, we need only the 2 points. Therefore, we will start from the domain. Our domain is x is greater than or equal to 2. Therefore, the numbers which are less than 2 are not part of the domain. In assigning the value of x, we are going to consider the domain of its specific subfunction. In this case, we are going to start assigning the value of x with 2 going to the right because our x is greater than 2. Therefore, x is equal to 2. Then after that, we are going to arrange, of course, the values of x. Therefore, the second value of x must be 3. It could also be 4 as long as it is greater than 2. But avoid to assign value of x which is a fraction or decimal for you to have a very good graph. And it will not give you a difficulty in plotting the points if the coordinates are fractions or decimals. Now, take note, our domain here is x is greater than or equal to 2. Therefore, do not assign the value of x which is less than 2. What are the integers which are less than 2? You have 1, of course you have 0, and you have the negative numbers. And these numbers are not part of the domain. Therefore, you are going to start assigning value of x which is 2 up to positive infinity. But take note, you need only 2 points to sketch the graph of a line. Therefore, if x is equal to 2, y is equal to 2 because this is an identity function. The prerequisite of sketching the graph of a piecewise function is be acquainted with the basic functions that we have already discussed. So if x is equal to 3, y is equal to 3. Now we will proceed with the second function which is a constant function, and if I am not mistaken, we have already sketched the graph of y is equal to negative 2, but take note our domain is x is less than 2, meaning 2 is not a part of the domain. But take note, there is a connection here because equal sign here is not included. Because if we are going to have the vertical line test, it will intersect the graph with 2 points. Therefore, if there is an equal sign here, there is no equal sign here. So you are going to consider this one. Now, how are we going to set up values for y is equal to -2? Since that our domain is x is less than 2, we are going to start assigning the value of x at the right side because our domain is going to the negative infinity starting with 2, but take note 2 is not a part of the domain. X is less than 2, but we are going to start assigning the value of x with 2 going to the left side. Now take note, constant function is also a line. Therefore, you need only 2 points in order to sketch the line. And this line is a horizontal line. Therefore, if x is equal to 2, where did we get 2? From the domain, take note. And why did we put 2 in the right side of the table? We are going to do that because our domain is x is less than 2. It means that our horizontal line has an arrow going to the left. What will be the second value of x? That is a number or integer which is to the left of 2, since we are going to follow the direction of the inequality symbol. Therefore, x is 1. You can also have the value of x which is 0. You can also have the value of x which is -1, or those integers which are less than 2. And avoid also assigning value of x which is a fraction or a decimal for you to get a very good graph or for you to not get difficulty in sketching the graph. But do not start assigning the value of x which is greater than 2 because the domain is x is less than 2. Take note, for our constant function, any value of x, the value of y remains constant at -2. Therefore, if x is equal to 2, y is -2. If x is equal to 1, y is also -2. Now, how are we going to sketch the graph? This is it. The first thing that we are going to do is to, of course, draw the vertical line and that of the horizontal line. This is the graph of a piecewise function given by y is equal to x if x is greater than or equal to 2 and y is equal to -2 if x is less than 2. Now, we are going to start from this particular table of values. If x is equal to 2, y is equal to 2. Where is that point? This point is found in the first quadrant. 1, 2, then move upward since our y is equal to 2. Then 1, 2. This is the point with coordinates 2 and 2. And we are going to proceed with the second point with coordinates 3 and 3. If x is equal to 3, y is equal to 3. Where is that point? 1, 2, 3. And move upward since our y is equal to +3. Then 1, 2, 3. This is our second point. Take note, if we are going to extend this line up to here, that is just only the graph of the identity function which we have already discussed. But since that our domain is limited to x is greater than or equal to 2, we do not have a line here. And this is just only a ray, wherein the endpoint is 2 and 2. The point with coordinates 2 and 2 going to the positive infinity. When we say infinity, it has no boundary. And it is being signified by this arrow to the right. Arrow to the right gives you a positive infinity. Arrow to the left gives you a negative infinity. Now, this is the graph of our subfunction y is equal to x, wherein our x is greater than or equal to 2. There are no values of x which are less than 2. The values of x start from 2 going to positive infinity. Therefore, this is just only a ray, wherein the endpoint is a point with coordinates 2 and 2. Now, we are going to proceed with this second table of values, which is the table of values for y is equal to negative 2. And this is a constant function, wherein the constant function has a graph which is a horizontal line. Horizontal line is a line which is parallel to the x-axis. But take note, our domain is controlled by x is less than 2. We do not have the value of x which is 2. The values of x will be less than 2. But take note, we are going to assign x which is equal to 2, and we will just only put the open circle here. This indicates that 2 and negative 2 is not a part of this line, and this is a half line. Take note, since that this is a constant function, whatever the value of x is being assigned to it, our value of y remains constant at negative 2. Therefore, our y is negative 2 for the first point, wherein our abscissa is 1. And our second point, wherein our abscissa is 2, our ordinate is also negative 2. Now, we are going to sketch the graph of this point, 1 and negative 2. Where is it? This is 1 for x and negative 2 for your y, going down. So, 1, 2. Take note, you are going to have the close point or the shaded point here because the point with coordinates 1 and negative 2 is a part of our subfunction y is equal to negative 2 if x is less than 2. Our second point of concentration is 2 and negative 2. And where is that? 1, 2, move downward 2 units because our y is negative 2. This is 1, then 2. Do not have the shaded point here because if you're going to shade this one, this indicates that the point 2 and negative 2 coordinates is a part of this line. But take note of our domain. Our domain is x is less than 2. Therefore, this is an open circle signifying that this point with coordinates 2 and negative 2 is not a part of this line. And this is just only a half horizontal line or half line. That is the difference between a half line is there is no endpoint, wherein ray has the endpoint. It means that half line is just a subset of a ray. Now, if we are going to draw a vertical line here, our vertical line intersects only the graph at one point only. So therefore, this is a function. Now we will proceed with the second function, which is composed of three different subfunctions with definite subdomain for each function. Take note, each subfunction has a definite rule because our first function is a quadratic function. The second function is just a horizontal line, or this is a constant function. And the third function is again an absolute value function because that is y is equal to x. Our first function is y is equal to x squared if x is greater than negative 1. And our second function is y is equal to negative 1 if x is greater than negative 4 and x is less than or equal to negative 1. And the third function is y is equal to x if x is less than or equal to negative 4. Now take note, in these two functions, there is a common abscissa here. But in this abscissa of the point, negative 1 is not a part of x. it should not be part of x, because if we are going to put equal sign here and there is also an equal sign here, that will violate the concept of a vertical line test for a function. Now, there is also a common abscissa here, which is -4 for the second and the third function. This is less than only. There is no equal sign, and in this domain, there is an equal sign. If there is an equal sign here, this is no longer a function because that will violate the vertical line test. But take note, in every two functions which are beside each other, there is a common abscissa. And how are we going to sketch the graph of this piecewise function, which is composed of three sub-functions? The first thing that we're going to do is to have the graph of this. We are going to have the table of values for y is equal to x squared. Take note, we have already sketched the graph of y is equal to x squared, and this is the basic quadratic function. But take note, our domain is limited to x is greater than -1. This is the table. Since that this is a curve, because this is not a linear function, since that this is a curve, we need 4 points. Why? Because we have to sketch the graph very accurately. Then we are going to start from the left side of our table, going to the positive infinity. Since our symbol used here is greater than. If it is greater than, we are going to start from the left. If it is less than, we are going to start from the right for assigning the value of x. We will start from -1. Why -1? Because 0 is not a part of domain here. Your x is greater than -1. All numbers which are less than -1 are not part of the domain. So we will start from -1. But take note, -1 is not a part of the abscissa. But we are going to consider this so that we can have later on the so-called open circle for our point. This is -1. -1 plus 1 is 0. And this is the vertex of the parabola. Then 0 plus 1 is 1. Then 1 plus 1 is equal to 2. Then we are going to solve. If x is equal to -1, -1 times -1 is equal to +1. If x is equal to 0, 0 times 0 is equal to 0. If x is equal to 1, 1 times 1 is equal to 1. If x is equal to 2, 2 times 2 is equal to 4 because our exponent here is 2. Now, we are going to have a separate table for our second subfunction, which is a horizontal line or a constant function wherein our domain is limited to x is greater than -4 and x is less than or equal to -1. This is a separate table wherein, take note, you are going to just only consider the two abscissas here. -4. Take note, -4 is less than -1. -4 must be in the left side and -1 must be in the right side. Constant function is a line. Therefore, you need only 2 points. And you are going to grab this opportunity to consider only these two values of x, because if you're going to consider other values of x not indicated here, that will give you a wrong horizontal line with this limited domain. Therefore, you are going to consider this one, -4, and this is -4. Take note, whatever the value of x, our y remains constant with -1. And then if x is equal to -1, our y is also -1. Now we will proceed with the identity function. Whatever the value of x here must also be the value of y. But take note, you are going to start with -4 going to the left, and that is going to the negative infinity. And this is also a line. You need only 2 points. And this is the table of values for y is equal to x if x is less than or equal to -4. Now, you are going to start with -4 here, and you're going to put negative 4 in the right side of our table because you are going to the negative infinity. Do not start here because that will not give you a correct graph later on. This is your guide. Negative 4, start with here. If x is equal to negative 4, your y is equal to negative 4 because this is an identity function in which whatever the value of x is also the value of y. Now, if x is equal to negative 5, you can also have negative 6 here as long as you start with negative 4 because there is a common abscissa here. Take note of this one. And we have this negative 4. This is our table of values. There are 2 points. Now, how are we going to sketch this one? The graph of this piecewise function is composed of 3 different sub-functions. The first one is a quadratic function with a domain of x is greater than or negative 1. This is it. We are going to plot these points of our quadratic function y is equal to x squared. If x is equal to negative 1, our y is positive 1. This is it. Now, take note, do not shade the point because this point is not a part of the graph. Because negative 1 is not a part of the domain. Therefore, this is not included because of this inequality in which negative 1 is not a part of the value of x. We have the 0 and 0 and that is our origin. And this is the vertex of the parabola. Then 1 and 1, this is it. 1 and 1. And you have 2 and 4. Where is that? 1, 2, then 1, 2, 3, 4. This is it. These are the 4 points. Take note, you are going to connect this by a curve wherein the curve is being cut at the point negative 1 and 1 and this point is not included since negative 1 is not a part of the domain. This is a very cute parabola with a limited domain of y is equal to x squared if x is greater than negative 1. You are going to consider or write our domain because if you're going to write only y is equal to x squared, this is wrong because this parabola is cut at point with coordinates negative 1 and 1. How are we going to draw the graph of this? Okay, this is very simple because this is just only a horizontal line. Horizontal line is a line parallel to the x-axis. But take note, our domain is limited to x is greater than negative 4 and x is less than or equal to negative 1. If x is equal to negative 4 and y is negative 1, negative 4 is not a part of our domain. Therefore, this is our point. This is open circle. It means that this point is not a part of our horizontal line. If x is equal to negative 1, y is negative 1. And this is it. And this is a part of our horizontal line with limited domain because of this equal sign. If there is no equal sign, we have the open circle. If there is an equal sign, you are going to have the solid circle signifying that this is a part of the set of points for that particular graph. And this is open circle signifying that this is not a part of the set of points of this graph because negative 4 is not a part of the domain of the second sub-function. This is a horizontal line given by y is equal to negative 1 if x is greater than or negative 4 and x is less than or equal to negative 1. How about this function? function, which is identity function. Take note, we have already discussed the identity function, in which whatever the value of x must also be the value of y. You're going to start with negative 4, and negative 4 must be put in the right side of the table because you are going to the negative infinity. Greater than gives you positive infinity. Greater than gives you arrow to the right. If this is the case in which our x is in the middle, there is no arrow. If you have only one value of x in the inequality, that is the time that will be giving you an arrow or infinity symbol. Take note, arrow means infinity. Greater than gives you arrow to the right. Arrow to the right means positive infinity. Now here, we start from negative 4, and that is the value of x. And we have also negative 5, another value of x. And whatever the value of x must also be the value of y. This is negative 4 and negative 4. The point is negative 4 and negative 4. 1, 2, 3, 4. Then 1, 2, 3, 4. Take note, this is a part of the domain. Negative 4 is a part of the domain because you have the equal sign there. Therefore, you're going to have the solid circle here. And all of the points here must be solid circles because all of the points here are part of the set of the points of this particular subfunction wherein y is equal to x if x is less than or equal to negative 4. But we need only 2 points to sketch the graph of any line. No? Connecting this one, you have the arrow to the left. Arrow to the left is signified by less than symbol. And there is an equal sign here. Therefore, there is an endpoint of our ray here. Now, there is no equal sign here, and this is open circle. And in this side, in the left side, negative 4 is not part of the value of x, and therefore this is open circle. And to the right of our x, there is an equal sign. Therefore, this is solid circle. And this is the graph of our piecewise function. Take note, in each subfunction, you are going to specify its equation together with the domain. And we have also here, y is equal to negative 1 if x is greater than negative 4 and x is less than or equal to negative 1. This is a horizontal line with limited domain values of x. And this is y is equal to x if x is less than or equal to negative 4. Actually, all of the functions being given as a part of our piecewise function is just only a basic function. And the problem is the domain. So we will proceed with the third and the last example of piecewise function. Y is equal to 1 half x plus 6. This is a linear function in which our x is greater than negative 4. The second subfunction is y is equal to 2 if x is equal to negative 4. It is a form of a constant function. But take note, our x is just only negative 4. It means that this is a point function only. And this is the easiest function, is the point function. We do not include the point function in the basic function because that is a very basic function. We have only one point. The third function is a quadratic function opening downward. And this is given by y is equal to negative quantity x plus 5 quantity squared minus 3 if x is less than negative 4. Take note, we have the common value of x for the two subfunctions. We have also here, we have the negative 4 as the common value of x. Take note, this is a linear function. This is a constant function, but since that our x is only one value, and that is negative 4. It is no longer a constant function, but it is a point function already. And in this particular function, this is a quadratic function with vertex negative 5 and negative 3. Actually, the functions here are just only basic. It is just only complicated because of multiple functions that we have with different subdomain. Now, we are going to have this separate table of values for the first subfunction, which is a linear function. Y is equal to 1 half x plus 6 if x is greater than negative 4. Take note, you are having a sign which is greater than. That will be giving you a positive infinity or arrow to the right. Our negative 4 must be put here. Since that this is a linear function, you need only 2 points. Therefore, if x is equal to negative 4, we have negative 4 divided by 2 is negative 2. Negative 2 times 1 is negative 2. Negative 2 plus 6 is 4, or 6 minus 2 is 4. I will repeat. If x is equal to negative 4, negative 4 times 1 is negative 4. Negative 4 divided by 2 is negative 2. Plus 6 is equal to 4. That is another way of finding the value of y. Because if we're going to multiply it first, that is also correct. If we're going to divide it first, that is also correct. The answer will not be affected whether you're going to multiply first or to divide first. Just a while ago, negative 4 divided by 2 is negative 2. Negative 2 times 1 is negative 2 plus 6 is negative 4. In assigning the value of x, you are going to consider the values which are divisible by 2. Therefore, we have here 0. You can also have 2 here. You can also have 4. Any number as long as it can be divided by 2 so that you will not have a decimal result for the value of y. Now, we have a 0 here. If x is equal to 0, this is cancelled out because 0 times 1 half is equal to 0 plus 6 is equal to 6. And these are the 2 points for the subfunction y is equal to 1 half x plus 6 if x is greater than negative 4. We don't need a table of values here because this is just only a point which is in the second quadrant. We will proceed with the third subfunction, which is a quadratic function. Now, take note, this is a quadratic function. This means that it is a curve and our domain is limited to x is less than negative 4. We need 4 points. Therefore, this is our table. We are going to have the less than here. It means that that will be giving you the values of x will be arranged from negative 4 going to negative infinity. Therefore, our negative 4 must be here. Although there is no equal sign here, but in assigning the value of x, you are going to always start with this because that will just only give you an open circle by and by. Take note, this is less than, therefore, the values of x must be arranged going to the left. And we are going to always follow the number line. It means that from left to right is increasing. So therefore, this is negative 4 minus 1 is negative 5. Negative 5 minus 1 is negative 6. Negative 6 minus 1 is negative 7. Our vertex is negative 5 and negative 3. And this is it. This is our vertex. Take note of these symmetric points. Symmetric points are points in which we have two different abscissas with same ordinate. This is our vertex. But we don't need the graph here. Therefore, we do not have the values of x here anymore because our domain is limited to x is less than negative 4. Now, if x is equal to negative 4, we are going to substitute. This is negative 4. Negative 4 plus 5 is 1. 1 raised to 2 is 1. 1 times negative 1 is negative 1. Minus 3 is negative 4. Now, if x is equal to negative 5, you don't need to solve it because it is the vertex. But we are going to check. Negative 5 plus 5 is equal to 0. 0 raised to 2 is 0. 0 times negative 1 is 0. 0 minus 3 is negative 3. If x is negative 6 plus 5 is negative 1. Negative 1 raised to 2 is positive 1. 1 times negative 1 is negative 1. Negative 1 minus 3 is negative 4. If x is equal to negative 7, we will use a scientific calculator, students. No, this is negative quantity. Our x is negative 7 plus 5. Close x squared minus 3. So, then, press equal sign. And the answer is negative 7. This is the graph of the piecewise function given by y is equal to 1 half x plus 6 if x is greater than negative 4. And the second subfunction is y is equal to 2 if x is equal to negative 4. Take note, the first subfunction of this piecewise function is just only a linear function. It looks like a constant function, but the value of x is just only 1, and that is negative 4. Therefore, this is just only a point function. And the third subfunction of this piecewise function is y is equal to negative quantity x plus 5 quantity squared minus 3 if x is less than negative 4. Now, we are going to plot the points of y is equal to 1 half x plus 6 if x is greater than negative 4. Our point is negative 4 and 4, and that is found in the second quadrant. So if x is equal to negative 4, 1, 2, 3, 4. And look for the value of y. If y is equal to positive, you are going to move upward. Since our y is equal to 4, from this initial point, you are going to move upward 4 units. So we have 1, 2, 3, 4. And this is our point with coordinates negative 4 and 4. Take note, since our domain is x is greater than negative 4 and negative 4 is not a part of the value of x, we have here the open circle with coordinates negative 4 and 4. Now, we will proceed with the second point of this subfunction, which is a linear function, 0 and 6. Where is that 0 and 6? The second point is our x is 0. Do not move to the right. Do not move to the left. Just proceed automatically with the value of y, which is 6. So therefore, you're going to move upward. 1, 2, 3, 4, 5, 6. And this is our point with coordinates 0 and 6. Take note, 6 is our y-intercept because our point is along the y-axis. And our abscissa, of course, is 0. Therefore, 6 is our y-intercept because this subfunction, which is a linear function, is in the form of slope-intercept form. Then after having the 2 points from this particular table of values, you are going to connect the 2 points with a half line. Why is it a half line? Because this point is not included. Then connect this one going up to there, and that will give you an arrow to the right. That means that this is going to positive infinity. our value of x starts from -4. -4 is not a part of x, going to positive infinity. And this is our graph, which is a half line. Take note, half line is just only a subset of a ray. The difference between half line and that of the ray is that ray has the origin or has the endpoint, while half line does not have the endpoint. That is why we have here the open circle. Now we will proceed with our second subfunction, which is just only a point function, and our point is given by x is -4 and our y is equal to 2. And where is that point? You are going to consider first the abscissa, which is -4, 1, 2, 3, 4. And our y is equal to 2. Move upward 2 units. Therefore, this is our point, -4 and 2. Take note, since our x is having an equal sign, x is equal to -4, therefore, this is a closed circle. And this is the graph of a point function y is equal to 2 if x is equal to -4. Now, we will proceed with the third subfunction, which is a quadratic function. And since that our quadratic term is negative, our parabola opens downward. And the third subfunction is given by negative x plus 5 quantity squared minus 3 if x is less than -4. We are going to have this table of values. If x is equal to -4, our y is -4. And that is in the third quadrant. 1, 2, 3, 4. And move downward. 1, 2, 3, 4. And this is our point being indicated by this open circle because our -4 is not a part of the value of x for the third subfunction of our piecewise function. Now, we will proceed with the second point, which is our vertex of our parabola. And that is -5 and -3. How did you get this point? So we have 1, 2, 3, 4, 5. Move downward 3 units. Then 1, 2, 3. This is it. Now we will proceed with the third point, which is -6 and -4. 1, 2, 3, 4, 5, 6. And our y is -4. Move downward 4 units. So 1, 2, 3, 4. This is the point with coordinates -6 and -4. Now, we are going to proceed with the last point, which is -7 and -7. Take note, all of these points are found in the third quadrant because all of the coordinates have a negative sign. Now, -7, 1, 2, 3, 4, 5, 6, 7. And move downward 7 units. Okay. 1, 2, 3, 4, 5, 6, 7. This is our point with coordinates -7 and -7. Now, take note, from the degree of the function, we can automatically think that this function is a parabola opening downward because this is negative. Therefore, do not connect the points with a line. Connect the points of the quadratic function with a smooth curve, in which this is open circle since -4 is not a part of the value of x. So, connect it with a smooth curve. Then don't forget to put the equation of the subfunction beside our graph because that is an indication that this graph is given by the equation y is equal to negative quantity x plus 5 quantity squared minus 3 if x is less than -4. And this point function is given by this equation, y is equal to 2 if x is equal to -4. And this subfunction, which is our first subfunction, is given by y is equal to 1/2 x plus 6 if x is greater than -4. Now, if we are going to draw a vertical line, we are going to have our vertical line here. That only intersects the vertical line at one point, and that point is our point function because we have here the open circle indicating that this point is not a part of this graph, and also this point, which is open circle, that indicates that this is excluded from the set of the values of the quadratic function given by this one with subdomain, which is x is less than -4. And that is the last example of piecewise function. This is your second assignment. I'm going to read the instruction. Copy and answer the following problems. Take a clear photo of your answer and submit it online through my email address, samsudinabdullah42@yahoo.com, or submit it in my messenger account, Samsudin and Abdullah. This is your assignment, students. This is the instruction. Construct a table of values for each function. Then sketch the graph accurately. Number 1 and 2 are constant functions. 3 to 4 are linear functions. 5 to 7 are quadratic functions. 8 to 10 are cubic functions. 11 to 12 are absolute value functions. And 13 to 14 are piecewise function. This time, we are going to discuss about real-life situations represented by functions. Various types of relationships or real-life situations apply the concept of functions. We have the examples. Distance is a function of time. Yes, because if you are going to travel or just only walk, the distance that you're going to travel is depending upon the time. It means that the time is independent variable and distance is our dependent variable, because you cannot have the distance if we do not have our time. Time can be denoted by a variable t, and distance can be represented by a variable d. Number 2. Height is a function of age. Age is our independent variable and height is our dependent variable because our age will determine our height. As the children go older, their height becomes longer. That is why height is dependent from the age. Number 3. A weekly allowance is a function of the hourly pay rate and the number of hours worked. If you are working as a part-timer in a certain fast food, your weekly salary is determined by the number of hours you work for each day. And for that day, you are going to compute if hourly pay is, for example, 300, and for one day, you will be working, for example, 8 hours. You're going to multiply 300 by 8 hours. Then how many days are you going to work for a week? And that will be your weekly salary. Therefore, weekly salary is dependent variable and hourly pay and the number of hours worked is independent variable. Number 4. A circle's circumference is a function of its diameter or radius. Diameter is our independent variable and our circumference is our dependent variable. Now, the equation would be C is equal to pi d. D is our diameter and C is our circumference. Then we can also have another formula which is C is equal to 2 pi r, wherein radius is our independent variable and C is our dependent variable. Okay, number 5. Price of a rice is a function of its weight. Yes, because if we are going to buy 25 kilo rice, the amount is less than the price of the 50 kilo rice or the one sack of rice. Therefore, weight is our independent variable and price is our dependent variable because the price is depending upon to the total number of kilos. Number 6. Government employee's salary is a function of a month he has been working in his workplace. Yes, because the shorter your length of service in the workplace, the lower the salary that you have. The longer you will stay in your workplace, the higher the salary that you have. Therefore, government salary is our dependent variable and the month that we have been working in our workplace is the independent variable. Okay, number 7. Amount of sodas coming out of a vending machine is a function of how much money is being inserted. Because if you're going to insert 10 peso, the amount of sodas coming out is less than the amount of soda coming out if you're going to insert 20 pesos or higher. Therefore, the amount being inserted is our independent variable and the amount of sodas coming out of a vending machine is our dependent variable. Number 8. Compound interest is a function of initial investment, interest rate, and time. So we will be talking about compound interest in the second branch of mathematics of this general mathematics. That will be in the second quarter. Compound interest is our dependent variable and we have 3 independent variables. Here we have the initial investment and this is our capital. We have the interest rate and we have our time. Number 9. An area of a square is a function of the square of its side. Side is our independent variable and the area is our dependent variable. The formula is given by A is equal to S squared where S is the side of the square. And last, number 10. Volume of a rectangle is a function of its length, width, and height. The formula will be V is equal to L times width times height. And our dependent variable is the volume. And there are 3 independent variables. We have the length, width, and height. And the formula will be given by V is equal to L times W times height. That ends our lesson for this day.